Graph the function shown, identify the period, the domain, and the range. So the parent function is f of x equals cotangent x, and then we have two transformations. This first one is a horizontal, and it's a stretch by 2. And the second one, this minus 3, is down 3. Okay, now since there's a translation, what I'm going to do is I'm going to graph the function g of x equals cotangent of 1/2 x, and then I'm going to translate that down 3. Okay, now we have a horizontal stretch by 2, which means the period is 2 pi. So what I'm going to do is I'm going to change colors here to a gray, and then I'm going to graph the function g of x equals cotangent 1/2 x. Then after that, we're going to translate it. The period is 2 pi, so that means we're going to have an asymptote at the y-axis, another asymptote here at 2 pi. Okay, now the x-intercept is going to be halfway between the asymptotes, and the key point's halfway in between those. So pi over 2 and then 1, 3 pi over 2, negative 1. So the original graph would look something like that. The g of x equals cotangent 1/2 x. But now we're going to translate down 3, which means moving the midline. So the midline is going to be down to negative 3, and I'm just going to draw that. Boom. So now it's going to be the same type of process. I'm just going to move the pi down, move the key points like that. It's just going to look something like that. That's one period of the function, and I could draw another one over here. So now with my other asymptote over here at negative 2 pi. And I just use the same type of key points. Halfway in between is at negative pi. Then halfway between each of those takes you to negative 3 pi over 2, and then up 1 from the midline, but it's really at negative 2 overall. And then down 1 from the midline at negative pi over 2. Okay, so there's a graph of the function f of x equals cotangent 1/2 x minus 3. We already identified the period at 2 pi. What's the domain and range? Well, the domain, you have a pattern with the asymptotes. You have an asymptote at x equals 0, and then at every 2 pi. So I'm going to create a little space here to write the domain and range. The domain. X is an element of the set of real numbers such that x is not equal to 2n pi. So what that means, n is going to be an integer. So if you had a 0 for n, it would be 2 times 0, or just 0 pi. Then if n equals 1, it would be 2 pi, and then 4 pi, and then 6 pi. And for the negative values, if n is negative 1, it would put you at negative 2 pi, negative 4 pi, negative 6 pi, and so on and so forth as the n decreases. So that's how you create your pattern of your asymptotes at every 2 pi. Now for the range, y is an element of the real number set. That's all you need to say. Because the cotangent function increases infinitely and decreases infinitely. Okay, so there's our graph. There's our domain and range. There's the period of the function.